All right, let's do number 18 and number 50. So number 18 says simplify the given expression. And we've got this guy. Can't really circle that with a white marker. We got this one on the bottom. So what does that look like? It's sine cosine minus sine cosine. We didn't have any of our identities look like that, right? The closest thing we had was sine cosine and cosine sine. But notice at how they organize it. This is a very common thing. Different books and groups will organize things differently. Number 18 is the same thing as sine 2x cosine 5x minus cosine 2x sine 5x. It's the same thing. Just a lot of people prefer one way over the other. And I like it in the way that I've just written it. So it is still that formula for sine. Now, is it angle sum or angle difference? It's going to be angle difference because sine will always match. This will be sine of the first angle minus the second angle. And we can simplify. It's just sine of negative 3x. And I'll take this, I think, most of the time. There's one thing that we can really do that's going to make this a lot better. Remember that sine's an odd function. And odd functions have the property of this. A negative on the inside is the same as a negative on the outside for an odd function. Think of x cubed, right? X cubed works like this too. That's an odd function. So we really can simplify this to become negative sine of 3x, like so. And that's the answer. Let me know if you have questions. I also wanted to do number 50, prove the identities. Sorry, it's a little dark or a little small. But let's start with the left-hand side. Again, we have angle sum on one side. We don't have it on the other side. So we're going to need those formulas. So that'll be cosine of the first, cosine of the second, minus sine of the first, sine of the second. It's always opposite signs for cosine. Gotta make sure I have the right formula. I do. So that's just the first part. But then it's also multiplied by cosine of x minus y. Just cosine x, cosine y, plus now sine x, sine y. Remember when I said a lot of these identity problems are really just issues of algebra? True for trig identities, maybe not true for our identity problems. Anyone ever having an identity crisis? I don't think algebra is probably going to fix that, but maybe. But this looks intimidating. You can FOIL this out the whole way if you want, or you can use a formula. Because what this really is the difference of squares. This is something minus something else, and that same something plus that something else. So if you use this formula, you're going to save yourself. If you can recognize this, you'll save yourself a little bit of time and effort. So what's the first thing squared? Well, that's, I don't want to still be in red. That's going to be the cosine squared of x, cosine squared of y, and then minus the second thing squared. Sine squared of x, sine squared of y. Which, wait, hold on. I'm losing myself. Okay, great. So now think of where we're trying to go. Hypothetically, if we paused a little bit, we're trying to get to cosine squared of x minus sine squared of y. Okay. Yeah. All right, I don't see it at a glance. I don't see anything we can factor. Can't use a Pythagorean identity, or can we? Could we maybe use a Pythagorean identity? I don't know if this is the right way, but sometimes it's worth a shot. So what is the problem here? Look at where we're trying to go and look where we're at. What I see, and it did stump me for a second as well, which is, I did choose this problem because I thought it was going to be tricky. We have a cosine squared in that first term, a cosine squared of x. That's great. We don't want this, but we can't really simplify it. What's another way to get rid of a cosine squared term? Pythagorean identity. Let's try it. Again, I don't know if this is going to work, but we can get rid of it, and then that'll give us a sine squared of y. And then maybe we can do some simplification because we'll have sine squareds of y in both parts. So let's see if it actually works or not. Cosine squared of x times 1 minus sine squared of y. We're using the Pythagorean identity on this guy. Minus sine squared of x, sine squared of y. And remember, you say, well, Jason, we have the same issue over here, right? Don't we want to get rid of this? Well, if we got rid of that, it changes it to cosine, and then we've just flip-flopped. We want them, we want everything to kind of match. So if we do this, we get cosine squared of x, let's distribute, minus sine squared of y, cosine squared of x, minus sine squared of x, sine squared of y. Okay, doesn't look great, but hey, look, this part matches now. So that's progress maybe. And what about this part? We can factor. I think this is right. I think we're getting there. Because we already have the first part. And if we factor out, let's factor out a minus sine squared of y. We're left with a cosine squared of x plus a sine squared of x. What is that? That's 1. What's left over? Cosine squared of x minus sine squared of y, just like we wanted. Okay? So this right here is the trickiest step over here. I cannot stress enough and I want to encourage you to do what I did, because I don't know all the answers either. You're not going to know all the answers, definitely. So if you ever get stuck, if you ever get paused, if you ever don't see where to go, always try to figure out, well, where are you trying to go? And how could you maybe get there? You don't need to know the right answer. I didn't know the right answer. I just made a guess. And then I worked with it. And if it was wrong, I'd erase it and try something else. So yeah, that's a good recap of what to do there. We see, okay, well, we got the cosine squareds, which is great. We needed to try to get rid of this somehow, but we couldn't factor it because, yeah, this thing over here was a sine squared, so we could get them both into sine squareds. Anytime, yeah, that's basically what happened. So good showing of what to do when you get confused. Let me know if you have questions. Good luck.